Okay, is better now? Okay, so I was saying the main topic will be to present what should lead soon to a very neat example of holography beyond the ADS-CFT paradigm. Okay, let's start. So we are taught that we can understand the duality between ADS5 cross S5 string theory and unequal 4 super-Yang mills by looking at the coupling limit of a stack of D3 branes. And something similar can be done for a stack of NS5 branes. And this leads to a duality where the bulk theory is a string theory in a geometry that is asymptotically linear dilaton. It means your dilaton is linear in the radial coordinate. And the dual theory is a 6-dimensional theory, rather mysterious, and the name is known as little string theory. And we'll learn more about this during the talk. So let's look more closer to this, how this decoupling limit works. So you start from a stack of parallel NS5 branes. So you have some flat directions along the brane, and then some harmonic function for the directions perpendicular to it. And you can, if you want to isolate the physics on the brane from what is happening in the bulk, you can you scale to 0 G string and R at the same rate. So technically you replace something like R equal G string times e to the rho, and you take the limit, you end up indeed with a dilaton that is linear in the radial coordinate. And the geometry that you obtain has a flat 6-dimensional Minkowski, a linear dilaton direction, and the 3-sphere that you can model from the worksheet as an SU2 Vezzomino-Witten model. And this subscript 1 means is the supersymmetric one. Okay, what's the problem with this? The problem is that rho, which runs from -infinity to +infinity, is not bounded. So this means that the dilaton is not bounded and your string coupling can explode. So you have a region where perturbative string theory doesn't apply. Okay, how can you solve this? So you can, instead of having the NS5 branes all together parallel, you can distribute them in a circle and repeat a similar decoupling limit where you scale G string and the radius of the circle on which the NS5 branes are distributed at the same rate, keeping alpha prime and the ratio fixed. And this leads to a background where you have some cylinder. So this is again the radial direction. Again, the dilaton grows as you go into the bulk, but it saturates at the tip, and the value of the dilaton at the tip is a modulus of the theory, so you can choose a small value, and then the string coupling can be adjusted to be small everywhere. And in the region closer to the boundary, this looks like a cylinder, and the radius is the string length times the square root of N5, which is the number of how many NS5 branes I have. Okay, and this can also be studied from the perspective of worksheet CFT. And you have the cigar is modeled by this SL2R over U1. Again, is supersymmetric, and the level is equal to how many branes I have. And similarly, the rest of the metric is given by SU2 over U1, and you have some flat directions. So we start from 3 plus 3, 6. You take 2 directions out, so this is a 4-dimensional space, so in total 10 dimensions as usual in string theory. Now, an equivalent formulation, you can re-express this. It's not obvious, but has been checked thoroughly, that an equivalent formulation is having a unique denominator. You have, again, SL2R and SU2, both the supersymmetric version of the Vezzomino-Witten model, and you do some null gauging. Again, you take away 2 U1s. And this will be the protagonist of this talk, and will play mainly with this object. So this is kind of the motivation of why we start with this worksheet CFT. Okay, so this is... Okay, so why this whole is interesting because the boundary theory that you obtain once you decouple the gravitational degrees of freedom is a six-dimensional theory without gravity, but it's not a local quantum field theory. So, for example, has some features that are more typical of string theories, like it obeys T-duality, and it has a Hagedorn rate of growth at high energies. And part of the reason why we don't understand much of this theory and we don't have a first principle definition is because it's both strongly coupled. So essentially you have scaled G string to 0. So all the scales that remain in the problem are alpha prime, which is not small a priori, hasn't been scaled at all, and the separation between the branes. So in general, it's a strongly coupled theory. And it's non-abelian because they have a large number of branes, so you can have interactions between the different branes. Okay, so how to approach this? One possibility is to think, okay, both difficulties should become much simpler if I have just one brane. So the easiest is, okay, it should be abelian because there are no strings or d-branes stretching between different NS5 branes. And the cartoon, this is not really rigorous, but the cartoon that you can sell is that you remember the cylinder that described the throat in the geometry has a radius that scales with square root of n5 times the string length. So when you have n5 equal 1, the throat is of the same size of the string. So essentially the string doesn't fit there, and it means it will not get to approach the strongly coupled region, which is deep in the bulk where the dilaton explodes. So it's a bit of a cartoon, but the intuition is that everything should simplify if you have just one single NS5 brane. Okay, so this intuition is an old one, but the reason why it hasn't been studied for long is because there are technical problems in defining just the theory of one NS5 brane. And that's the goal of the talk. So we want to give today a worksheet definition of string theory for a single NS5 brane and explain how the common law of this not been possible because of well-known technical problems that I'm going to review can be overcome. And ideally, once we understand this, we will see that this is a free theory with some constraints, so it's amenable to an exact analysis. So one should be able also to study the states that this string theory contains and get to some guess of what the boundary dual should be. So it should be some six-dimensional supersymmetric abelian theory. And ideally, one can get to an exact solution of the duality because it's a special regime where things should simplify a lot. And this should give something like the analog to the tensile string, but of ADS3, but in the case of this little string theory, holography, where we are a bit lost when the number of branes is a generic number. Today, I will just address the first line. I will try to convince you that we have a string theory that defines rigorously and overcoming these difficulties when you have just one NS5 brane. Okay, so we said that we start from this when the NS5 branes are N5. So the naive guess is, okay, wherever I see N5, I replace 1. Now, the problem with this is that you have the SU2 Vezzumino-Witten model, the supersymmetric one. This you can rewrite into a bosonic contribution that shifts the level down by 2 and free fermions. And the problem is that doing this way, the bosonic part has negative level. So the Vezzumino-Witten model associated to it is not unitary. And this is the reason why, so far, we have said, okay, what should I do? This is not a well-defined string theory. It doesn't really make sense to set N5 to 1. Okay, but relatively recent in the history of this NS5 brane problem, we have encountered a similar problem that smells the same and has been solved. So for the tensionless ADS3 cross S3 cross T4 string, again, you have an SL2R factors for ADS3, an SU2 factor for the S3, and then 4 free bosons and 4 free fermions. And again, the problem was that if you really want to insist on N5, the number of NS5-brane in the background being 1, you had the SU2 at level -1. So same problem, it looks like. Oh, this is bad. Very bad. Okay. Let me, it's already the end. Okay. No. Okay, so what was the solution? The solution was to rely, and let me describe first at N5 bigger or equal than 2, you have a map between two different formalisms, the RNS formalism, which is the one we are used to, and the Berkowitz-Vafa-Witten formalism, where you bosonize your free fermions. It's just a bosonization map, so it's not something really mysterious. It's just a redefinition of variables. And you keep the bosonic part. So you have SL2, the supersymmetric, you decouple, you shift the level, you have the bosonic part. Same for SU2. And you have 6 free fermions. You bosonize the free fermions together with the ghosts. And what you obtain is 4 BC systems of dimension 1, 0. So this is just a map that you have at N5 bigger or equal than 2. And in terms of these free fields, you can, in terms of these fields, you can generate PSU112. So the associated superalgebra. So naively, you start from SL2R and SU2, and you replace with a supergroup. This at N5 bigger or equal than 2, when both sides are well defined. Somehow at N5 equal 1, this doesn't really have a meaning, but it does have at N5 equal 1 what is on the right. So PSU112 level 1 is well defined, and this was essentially, in a nutshell, the solution for the tensionless string. Moreover, the PSU112 level 1 has a free field realization, so this means computations are easy. And is given in terms of 1 beta gamma system. For the specialists, this is the beta gamma of Wakimoto-like, and 2 BC systems. And you can generate all the currents in PSU112. Okay, so given this, can we learn how to solve the problem for the single NS5-brane in the little string theory holography that I was describing? We are ready for a refined guess then. We said we cannot really set just N5 equal 1 blindly in the RNS formalism, but we can take the supergroup, so take the tensionless string of Eberhard, Gaberdil, and Goppa-Kumar and quotient that. That should solve the problem. Unfortunately, this doesn't really, and the obstacle is that if you look more close to the currents that you want to gauge, those don't have, you are not able to write them in terms of the free fields or of the generators that are contained in PSU112. So if I have to make an analogy, you know, when you play Scrabble, the game where you have to form words out of letters, you want to write a very long word, but you have only vowels. That's kind of the problem. And let me try to be more precise. So we saw that N5 bigger or equal than 2, you can generate PSU112 in terms of the bosonic algebras and 4 BC systems. But at N5 equal 1, you only have 2 BC systems. And the current that you want to gauge is written in terms, at N5 bigger or equal than 2, is written in terms of the BC systems that you miss. So, okay, what should we do? So the strategy that we follow is to insist on extending the map between RNS and hybrid formalism. So if you take the bosonic algebra and blindly set N5 equal to 1, you have SL2R at level 3 and SU2 at level -1. We provide a free field realization for these two. So we end up with describing SL2 the bosonic part at level 3 and SU2 at level -1 in terms of 3 beta-gamma systems. Of course, this alone cannot solve the problem, because we said the problem of the initial formulation of blindly setting N5 equal to -1 is that the model is not unitary. So yes, you have a map between something non-unitary and something non-unitary. So it's not really on its own a solution. Anyway, you can write down PSU112 at level 1 in terms of 3 beta-gamma systems and 4 BC systems. So now you can write your current, but the model is non-unitary. And here comes the solution. So we identify a constraint which is given in terms of the free fields that form these bosonic algebras, and in terms of these 4 BC systems that restores unitarity. And also we can show that this new formulation is completely equivalent to the tensionless string. So if you look, for example, at representations, you find the same truncation in the spectrum that kills the continuum, and you find the same null vectors that are responsible for it. So essentially, you reformulate the tensionless string in terms of an enlarged space. You have more than twice many of the fields, but you also have an additional BRST constraints. And in the end, you have the same PSU112 with the advantage that now you have more letters in your alphabet. So you can indeed write the current. Okay, so to recap, the solution is that we adopt an alternative new free field realization of PSU112 level 1 that has an enlarged number of fields and that enjoys a map to RNS. We impose an additional constraints that restores the unitarity of the model. So in a sense, now you can go back through this map and you can see in which sense the RNS formalism at level 1 was sick and which is the cure. And we prove that our formulation is completely equivalent to the previous one if you use PSU112 for the tensionless string. So this defines a worksheet formulation of the single NS5-brane string theory in terms of a free field worksheet CFT, those that generate PSU112 level 1, and in terms of 3 BRST constraints, and we show that they are mutually compatible, meaning the total BRST charge squares to 0, so we can impose all of them one after the other. And these 3 BRST constraints are the usual one we are used to, that decouples 2 directions that any string theory has. An additional one that comes from the fact that we are gauging something in the denominator, so it's the null gauging BRST operator. And finally, the one which is special to N5 equal 1, and that restores the unitarity. Okay, so now there are many open future directions that we would like to explore. We just have defined the string theory. So we haven't yet studied what is the spectrum, what it contains. So you would expect the first exercise, you would expect, for example, to recover a number of supercharges that is expected from the boundary theory. So you want to recover something like n equal 2 super Poincare. And on top of that, it should also contain some fields. And the natural expectation is that the dual is some 5 + 1 dimensional abelian gauge theory, and that this should be identified by studying the BRST cohomology. It would also be very interesting to study correlation functions. So we know that the correlation functions of the tensionless string localize, meaning all the physics is concentrated to the boundary. And holographically, the radial coordinate in the bulk is the one that drives the RG flow of the boundary. So the fact that the theory you are quotienting sits always at the boundary suggests that the boundary theory doesn't flow, but is always the IR solution. So the natural expectation is that you get the IR limit of little string theory, which is indeed a QFT. So something like n equal to 2 Maxwell or the abelian 2,0 6D superconformal field theory, according to the chirality. And finally, you can change the embedding of the currents you're gauging. So in this whole story, the R15 was a spectator, but you can bring two directions of the R15 in the numerator, so that your U1s are linear combinations of the cartans of SL2, of SU2, and also the two extra U1s. And this describes a background that interpolates between ADS3 and asymptotically linear dilaton, and that is naturally believed to be dual to the single trace TT bar deformed symmetric orbifold. So even if we solve this problem, there is also more interesting setups to extend to. So this is all I wanted to say. And thank you very much for your attentions. We learned that NS5-branes are better alone, but physicists are not. So please make my week very strongly coupled and non-abelian. Thank you very much.
A clarification. So you said, if I understood correctly, that this free field realization of PSU 1,1 /2 level 1 in terms of one beta gamma system and 2BC system. So you said that doesn't have the U1s for the gauging, but I suppose you meant they're just not convenient in that formally, because of course it has all the U1, they're just cartans, right? It has everything.
You're right. I was hiding details in the So the currents you're gauging, they are supersymmetric. So you have the current you're gauging is something like the cartan of SL2 plus the cartan of SU2. And of course, you're right. Those you have, because you have a realization of the superalgebra, you know how to write them. But you also have to gauge a fermionic superpartner of this. This comes from the RNS formulation, where you don't want to break the supersymmetry on the worldsheet. So you also have to gauge something that is like the fermion dual to J3, so something like psi3 plus the fermion, which is the superpartner of K3. And what you actually are not able to write is the sum of the fermions times the associated ghost. You're right, this detail was hidden.
And as a small follow-up, is there something like a marginal direction Ramon flux that you can turn on in this story, or it doesn't exist?
Okay, so that's a longer story. I think the most interesting thing is that if you look at the PSU 112 Vezzumino-Witten model and you rewrite in RNS variables, so you find the SU2 Vezzumino-Witten model, the SL2, free fermions, but not just that. You also have an extra piece that looks like a Ramond-Ramond deformation. So the equivalence is not complete, except when you look at the N5 = 1, what we argue also in the paper is that the modes that are inside this free field realization don't care of this extra piece. So this extra piece is proportional to the constraint that imposes unitarity. So once the fields that survive this constraint don't see that extra piece in the Lagrangian that would erect an RR wall close to the boundary. So at least at N5 = 1, despite the initial Lagrangian is different, for all the practicalities, it is as if that Ramond-Ramond field is not there.
Oh, okay. Can I ask, or is someone? Okay. You mentioned this unitarity problem in the SU2. Yeah. Now, the way you presented it, it was sort of after decoupling the 3 free fermions from the SU2.
Yes.
But as I'm sure you know, the original supersymmetric SU2 model is not that. And then there's this nice paper of Paolo De Vecchia and Knishnik,
yes,
who showed that you can write it like this. Now, is the original model also, is a full model non-unitary as well?
So if I understand correctly, the original definition of the supersymmetric Vezzumino-Witten model is that you take the bosonic one where you had G minus 1 dG and you replace with a supersymmetric G, okay?
Yeah.
And you just expand. And my understanding is that if you do that, you find the bosonic plus the free fermions.
No, you have to do a field redefinition. This is what De Vecchia and others taught us.
Okay.
In order to get the 3. I just wonder, because you do all these translation of variables, if somehow it's related to the same thing that they were doing.
Okay, I'm not sure I understand. Maybe we can discuss later, but this translation is really nothing mysterious. It's just taking your 10 free fermions, you bosonize in 5 bosons, and then you write the new variables are exponential of the sum of these 5 bosons with different choices of plus and minus ones. So it's not something suspicious about.
I'm not, okay.
Okay, maybe we can discuss more. I'm not sure I fully understand the question, or I know the paper you refer to.
Just maybe conceptual question, not technical. So how you motivated this SU2 over U1 times SL2 over U1? You said, let's distribute the NS5-branes. That's fine, but that requires many NS5-branes. And then suddenly you jump back to NS5-1. So what's the logic? And also you probably missed the dilaton in this case that has 2 contributions. Logarithm of cosh and logarithm of cos of sigma. You have sigma and rho, right? Yeah, anyway, could you again explain the logic? So the outcome, you can postulate whatever you want, but why it has to do with NS5 equal 1? That's the question.
Okay, so you mean, okay, I see. So you're saying you have already decoupled and that formulation is only for N5, I understand. Yes, I mean, I don't have another place to start from. I think it's natural to look at that N5 equal 1 limit, but I agree that I start from a situation where it's already decoupled. On the other hand, I don't have another worldsheet model to start from. So, I mean, this doesn't make obvious that the dual is what we claim. I think one can now just look at the field content. It's certainly a well-defined string theory. To fully sustain my claim, I should show what is the spectrum and show that I recover the 2,0 6D abelian theory. That would probably convince you. I agree. There is not all the evidence yet. Thank you.